These notes are for Honors Math 3. This is for Unit 9, and we're currently in the middle of learning how to sketch all the trig functions. So last week we went over how to sketch the sine and cosine graphs, and we were working on those equations. This set of notes is going to start with going over some of those problems from that assignment that were assigned, and then I'll continue on more specifically with 9.9. That worksheet is more with sketching sine and cosine, with translations and changing the period length. So I'm going to start back here where we left off last week on the sine graphing paper and go through questions 13 and 14 here. All right. So use the 5 key points for the trig function to sketch the first period of the following in one color. Use a different color to expand the pattern in both directions so that it covers the whole graph. So just like what we were doing in class. So I'll remind you, the last thing we had seen here was how every trig function should be written in this form. You have a coefficient, a. This a value often tells you where you start, what its amplitude is. Positive, negative tells you which direction the function is moving in. The b value affects the period length, and for any sine or cosine graph, the period length is given by 2 pi divided by the b value. You'll want to make sure that you always factor that value out from any parentheses you might have with x. And then c is your horizontal translation. D is that vertical translation. Okay, so down here on problem number 13, one thing I might do first is go ahead and take that 2 out. If I don't, it might appear that the translation is pi units to the right. So I want to factor out this 2. And all we're doing is factoring it out from the 2x minus pi. So I'm left with x minus pi over 2. Everything else stays the same. Let's get one more parenthesis in there. We take out that 2, we're left with x minus pi over 2. So the actual translation is pi over 2 units to the right, and as you saw earlier, 1 unit up. 2 is still the b value, whether it's in the parentheses or factored out, okay? And that's going to affect the period length. 4 is going to affect the amplitude. So 4 is our amplitude. And one thing you can actually do here before you get started is figure out what the max and min will be. So this can be helpful for a lot of people who are struggling just finding how high and how low to go and remembering how to find those values. So we can start by finding that first. So that leading coefficient, it should be your max and min. So you would start at 4, minimum, negative 4. But everything is translated up 1 unit. Notice a left-right translation would not affect how high or low the graph is, but a vertical translation will. So I want to add 1 onto both of these values and end up with 5 as my maximum and negative 3 as my minimum. So these are the actual values I'll end up with. All right, the equilibrium should be right in the middle of those 2 values. So to find the middle of any 2 numbers, you would average them and you would end up with 1. So your equilibrium should end up on y equals 1. So it does help if you'd like to kind of have a little dotted line in there to make sure your points end up in the right spots. So the equilibrium is 1. So let's talk about graphing a positive sine curve. So I always want my map start. We're going to go up first because it is a positive sine graph, and then down. And so we have the 3 points on the equilibrium here. My start, end, and the middle, which makes sine really easy to graph. We want to go to our maximum and then the minimum, again, because it's positive. So that very first point for sine likes to start on the origin, but this graph has been translated pi over 2 units to the right and 1 unit up. So I'm going to start by translating that very first point from the origin, pi over 2 units to the right and 1 unit up. So we'll start here at pi over 2, 1. So that's this point. To get to the last point from here, I want to add the period length, since the period length is always from the beginning to the end of the curve. So on the side, I'm going to use this side of my paper here. We're going to calculate what that period length is. 2 pi divided by b. So b was that coefficient of x, 2. And we end up with a period length of pi. So from beginning to end should be a total length of pi. To figure out where we should end up then, we have a starting point at pi over 2, and I want to add pi. Start at pi over 2, add pi, and where do I end up? 3 pi over 2, so 1.5 pi. So here's 1 pi, here's 2 pi, so this should be 1.5 pi, or 3 pi over 2. That's my last point. So now I go to the point right in the middle. So I'm on the equilibrium, I divide the space in half, and here we are. So now all I need is right in the middle of my first 2 points should be my maximum. Remember, the maximum is 5. So right in the middle here, all the way up to 5. And then in the middle here, the minimum is -3. Now, if you hadn't found those values first, remember that you can always use the amplitude to find that. So with the amplitude being 4, this means from the equilibrium up is 4 units, or the equilibrium down is 4 units. And so you could just count up 4 and count down 4. So this is going to give us the first period for pi, for sine. So we want to just continue the graph on in both directions with another color. We want to watch out that our spacing remains the same. So I might start by looking how far apart the points along the equilibrium are. So it looks like every tick marking, which is every pi over 2, I have another point here. So I'm going to keep doing that. So at 2 pi, I should have one. At the next one, at 3 pi, going in the direction left, same. And then we want to alternate maximum, minimum in between each pair. So between 3 pi over 2 and 2 pi, we should have our maximum. In between the next two, the minimum. And so there's another one. And again, we want to go maximum and then the minimum over here, but that's off our graph, so we won't draw it. And we'll do the same going backwards. So right in the middle here should alternate max now is minimum, -3. Right in between these two, my maximum 5. And right in between these two, my minimum -3. So it should look like the same curve over and over. So it shouldn't change heights. It should always be my minimum, my maximum, and appear to be the same size shape. So let's try that with problem number 14. Okay. This sine graph is negative. So it's first going to, just like the graph above on number 12, it will reach its minimum before its maximum. So that is what our mapping should look like. Okay, and you can actually determine the max and the min before you get started on too much. So you just look at that leading coefficient to get your amplitude. So the amplitude should be 2. Okay, so my maximum should be 2, the minimum should be -2. But the vertical translation up 2 will adjust that. So if I add 2 to both, you add it to everything, every point is moved up 2. 2 plus 2 is a max of 4. Negative 2 plus 2, a minimum of 0. So my minimums will be touching the x-axis. Let's look at factoring out that 3 here. So what I'd like to do is keep my negative 2, sign, factor out 3, x minus pi over 3, still have the plus 2. So the translation is pi over 3 right and 2 up. And with that 3 out front, that's going to affect the period length. So the period length is 2 pi divided by b, which is 3. And so that's it, 2 pi over 3. Pretty short. You'll also notice that the shift was pi over 3. So that's really nice. That makes the values work out pretty nicely together. What you might want to do now, though, is divide your graph into thirds. So right now, you have every pi unit marked and every half pi unit marked. So we're going to come in here and take pi and divide it into 3 sections. So 1 pi over 3, 2 pi over 3. Pi would be 3 pi out of 3. 4 pi over 3, 5 pi over 3. 2 pi would be 6 pi over 3. 7, 8, and then 9 over 3 is 3 pi. So I kind of want to ignore the tiny markings that aren't labeled in between mine. And then I also want to have pi, 2 pi, 3 pi. So these markings are the ones that I'll be looking at this time. We can do the same this way, negative pi over 3, negative 2 pi over 3, negative 3 pi over 3. So hopefully it looks like we divided the spaces into thirds. Let's take that first point here, which usually starts on the origin. We're going to translate it pi over 3 right and 2 up. So from here, pi over 3 to the right and up 1, 2. So that's going to be our very first point. Okay. How do I get to the last point? So I always go first, then last, middle. Okay, first, end, and then the middle. I do the same when I graph cosine. So to get to the end, we want to add our period to our start value. So we started at pi over 3. Pi over 3. We want to add the period length, 2 pi over 3. So if I add those together, I end up at 3 pi over 3, which is pi. So right here at pi, we should be all done with this period. Those are the first and last points of this curve. So there should be 1 right in the middle here. Right there. In between the first 2 points, we should have our minimum, which we determined was 0. So right here in the middle of these 2 points would be my x-intercept. And in the middle of these 2 points, my maximum would be 4. There we go. So we'll just repeat that using our different color. So I might notice the points along my equilibrium and how far apart they are. So every pi over 3, I've marked off a point on the equilibrium. So here, here, 2 pi, 1, 2, 3 pi. Same in the other direction. All right, and then we just want to alternate minimum, maximum. So in between the first 2, a minimum, the second 2, a maximum. Okay, connect these. So now again, in between these 2, a minimum. In between the next 2, our maximum. In between the first 2, a minimum, the next 2, the maximum. Okay, we'll just take this back. All right, so that's 13 and 14 on the sine graph. So we're going to switch back over to the cosine paper and just do one of those graphs there. So we're going to look at problem number 9 on the cosine graph. All right, so this one, you just have a 1 for your b value. So the period is still going to be 2 pi. So that hasn't changed in any of these problems here. We have an a value of 1/2. So that's going to give me my amplitude is 1/2. So the total height of the curve is 1 unit. Total height, 1. Pretty short. You can do the same that we were doing with sine and figure out the max and min before you get started. So positive amplitude, positive 1/2, should be the max. Negative 1/2 would be the minimum. Everything is translated up 3 units. So keep in mind that the horizontal translation won't affect that, but the vertical translation will. So we want to add 3 and add 3. So 3 plus 1/2, 3.5. 3 minus 1/2, 2.5. And so sure enough, that's a total height or distance of 1 unit apart. Right? Right in the middle, you'll have your equilibrium. So right at 3, that's where our equilibrium will be. This is a positive cosine graph. So we want to start and end on our maximums. Right in the middle, we have our minimum. Here's our equilibrium with the 2 points here. So let's start with cosine's first point. Doesn't start on the origin like sine, likes to start on its a value, 1/2, but we're going to apply our translation. So we want to go left pi units and up 3 units. So we start again at 1/2. We want to go left pi and up 1, 2, 3. So sure enough, that's my maximum right there, that first point. Maximum should be at 3.5. The other maximum is also up here at 3.5. We just need to know where. So what's the x value where that happens? So to find that, we take our start value. So I'm starting over here at negative pi, and we want to add the period length. So add 2 pi to get to the end. So negative pi to start. Add 2 pi, and we end up at pi. So by the time we get to pi, we're back here at our maximum 3.5. Right in the middle of those 2 points, so in the middle of these 2 points is your y-axis, we should have our minimum. So my minimum is 2.5 right here. And then we just keep dividing the space in half. So right in between negative pi and 0 is negative pi over 2. We should be on the equilibrium, y equals 3. Same thing over here. Remember with the points with cosine, those points should appear to lie in a straight line. We just want to make sure we connect with our curve. All right, so there's that period of cosine. We want to do one more. So I might notice that the points on the equilibrium, negative pi over 2, positive pi over 2, so 3 pi over 2, 5 pi over 2. You're going to see another maximum right over here at the other end. So every 2 pi units, we should see another. And then the minimum right in the middle. All right, and so that is problem number 9. So now we're going to look at a few problems from 9.9's worksheet. So you can see on this worksheet, 1 through 11 say to sketch the first period of the graph for each function. So you won't be having to include the graphs extended in each direction here. On 12 through 15, you're going to answer what's the maximum and where does it occur, what is the minimum, where does it occur, and then 16 through 19, where do the zeros occur. So you're just focusing on getting the graph right so that you can answer the question. So let's pick a nice even problem to go over from this section, number 10. All right, so I like this one because it's another cosine graph and we could use another example of it. It has everything going on. It has an A, a B, a C, and a D. So what I'd like to do is factor out that 1/2 value. That's my B value here, the coefficient of X. So we'll start 3 cosine 1/2 of X plus pi minus 2. That allows me to see A, the amplitude, B, which affects the period, C and D, the translations. So I have an amplitude of 3, so a total height of 6. Cosine, positive cosine graph, so that's going to give me my maximum, minimum, back up to a maximum. 1/2 affects the period length, so 2 pi divided by 1/2 gives us a period length of 4 pi. So by cutting our speed in half, right, we're lengthening the time it takes to get there. Pi is the translation to the left, and then 2 units down. All right, so we're going to start building our graph here. So cosine likes to start on its A value, which is 3. So we're talking about right here on the y-axis. But we would apply our translation here. So we want to go left pi units and down 2. So left pi, down 1, 2. So here we are at 1. So that should be the maximum, 1. So we can verify that just by doing what we did in the earlier problem. The max should be 3. It moves down 2. 3 minus 2 is 1. So here we are at a height of 1. And if you'd like to write it out, you can. 3 minus 2, 1. The minimum would be the opposite, negative 3. Still moved down 2. Our minimum should be negative 5. All right, so we have our first point. Let's get to that last point. If I'm starting at negative pi, I want to add the period length 4 pi to get to where I end up. That would be 3 pi. So pi, 2 pi, 3 pi. Right here at a height of 1. So there's my last point. Right in the middle, we should have our minimum. So in the middle of negative pi and 3 pi is 1 pi. So at pi, my minimum is negative 5. The equilibrium is right in the middle. If I average these two values, we get negative 2. So my equilibrium is running right through here at negative 2. And we just want to divide these spaces in half. So halfway between negative pi and pi is 0, the y-axis. Halfway between pi and 3 pi is 2 pi, right here on our dotted line. So that gives me those points for cosine, and then we can connect with our curve. So when you get to the questions below in problems 12 through 19, it says things like, what is the maximum? So here you would say the maximum is 1. Where does it occur? At negative pi and 3 pi. What's the minimum? Negative 5. Where does it occur? When x is pi. Okay. For the zeros, these aren't nice zeros. So not going to be a problem that we would necessarily be looking at. So I think you'll find that those graphs are a lot nicer looking if you just kind of glance at them. So let's go ahead and jump to a problem in the lower section. We'll look at number 14 here. So it does want to know, what is the maximum, where does it occur? What is the minimum, where does it occur? So we can pretty easily figure out the max and the min like we've been doing. So the amplitude is 2. My maximum then should be +2, the minimum -2. Everything is translated down 1 unit. So it's only with a vertical translation that changes. So down 1, down 1. And so this will give us the actual maximum is 1 and the minimum -3. Now there's no translation right or left. So this trig function sine is going to start right here on the y-axis. It's not been moved off the y-axis. And you can start doing as much of the graph as you need to answer the question here. So where we would start on the origin, it's been moved down 1 unit, -1. Remember, for sine, we have the first, middle, and end are the equilibrium points. So we have our max, 1. We have our minimum, -3. This right now is the equilibrium that we're on, -1. So we have our first point. The last point is the period length away. So notice the period is not 2 pi right now. Since b is pi, 2 pi divided by pi is 2. So this is 0, 1, 2. So right here, we get to the end of our sine graph. So that's the beginning and the end. The middle is at 1. And then right here, we're going to figure out our minimum comes first. So the minimum, -3, should be right here in the middle. So the middle of 0 and 1 is 1/2. So I know the minimum is -3. It occurs at x equals 1/2. The maximum occurs between 1 and 2. Halfway between 1 and 2, we get our maximum 1. So 1 occurs at x equals 1.5, 3/2, whichever way you prefer to write it. Okay. I think that's it. I hope that those will help you in graphing the remaining problems, and we'll be sure to go over some more problems in class.